Thank you so much, Rob, and thank you, Mr. Permanent Secretary, for your introductory remarks. I want to thank Charles Ng for running me around like crazy the last 3 days. If there's any way to get a sense of the energy that is in Hong Kong, it's to spend some time with Charles Ng, as he is busily setting up fantastic meetings, and I really feel like what I've taken away from that is a sheer sense of the drive to sort of get the innovation buzz happening in this place, and the amount of activity is really very impressive. So thank you very much for that opportunity, Charles, and thanks everyone for having me. Now, as Rob said, I have come a long way. Came from New York, where I live. I work at MIT up in Cambridge, so I'm constantly commuting back and forth between those two cities. But you know, the 16-hour flight from New York to Hong Kong is one of the longest in the world. And it's quite a trip, and I'm supposed to use that time to do work. I'm working on a book at the moment. I'm supposed to be writing a book. But of course, like most people, I end up, binging on the fantastic array of movies and the like that Cathay Pacific offers. In this case, I was watching episode after episode of Mr. Robot. And I don't know if any of you guys are familiar with that show, but it's a wonderful show about kind of hacker culture in the US. And I was struck by one of the scenes in it where two hackers in a kind of a staged mugging interact with each other. One of them, does a fake mugging of the others and demands their wallet. And I thought, that's kind of crazy. These guys are the most high-tech digital, guys in the world. They wouldn't be carrying a wallet, right? You wouldn't mug somebody for cash anymore. Certainly not in the US. People don't carry cash. And so it just seemed, I think about it, I thought, wow. Mugging as a business is really, suffering, right? It's going to get, it really isn't the way to make money in the crime business anymore, is to be a mugger, because it's just not, people aren't going to be carrying cash around. But the flip side of that, of course, is there's actually an enormous amount of money to be made in cybercrime. And that's really what I want to talk to you about today. Of course, this is a conversation about the blockchain and the power of this technology. But, a lot of you are familiar with the blockchain, I understand. This is a fintech crowd after all, so I'm not going to give you my classic speech, which is the primer on why this is important and the details of it. Rather, I'm going to just talk to you a little bit about the structure of kind of the blockchain, just as importantly, the mindset around it, and why this is a different security paradigm for the future. And the future, of course, involves things like IoT. And therefore, it's an enabling technology for this incredibly interconnected machine-to-machine, peer-to-peer world that we are building, with all the smart city and sort of smart energy and distributed structures that we're talking about as this kind of exciting new future. It won't be possible, in my mind, without the blockchain. So I'm going to talk to you about why that's the case. I'm going to start with this story. You might be familiar, those of you who know what DIN is, but more importantly DNS. There was a massive DDoS attack, a distributed denial of service attack, a few months ago on DIN. DIN manages DNS for lots of companies, some of the biggest in the world. And effectively what happened is a bunch of hackers, anonymous, basically put a claim to being responsible. We're not sure if they were the case or not, launched this attack using underprotected IoT devices. So the idea is that people aren't updating their IoT devices properly. You kind of put let's say, the smart doorknob, right? There's this classic idea of the smart doorknob. You put it in there, nobody updates it for all of the software updates. And so as a result, they're very vulnerable as entry points into these centralized systems. And essentially, by sending massive requests, DNS requests, through to DIN, it shut down the entire network, and it meant that Twitter and I think Facebook and a bunch of other sites weren't able to function at that time. And to me, this was quite indicative of the challenges that we're facing right now. And one of the things that we're seeing is just, and this is, I apologize for being kind of US-centric here, but these are the kinds of attacks that we've seen over the last couple of years, all of them, quite high profile. And I think this is indicative of a contradiction that we are encountering in the world right now, whereby there is a increasing centralization of information in these entities, right? The servers of JP Morgan, of Home Depot, of Wendy's are increasingly getting more and more data inside them. These are credit card numbers and all sorts of data. At the same time that we are decentralizing the access points. So we're moving out, building IoT connections, we're building peer-to-peer finance, we're building digital currency connections. All of that is a hacker's dream, right? Because there's these vulnerable entry points and a gigantic honeypot of data to get into. We need to fix this problem. Just to give you a sense of the scale, that number is one that was produced by Lloyd's of London, and obviously Lloyd's as an insurance company have got a pretty good grip on how serious things are because they're the ones that are forking over the money when the business claims come in. It's not obviously all of the money going into the hands of the hackers because that truly would be a wonderful crime business to be in, but it's rather the losses, the lawsuits, the restructurings, the amount of spending on cyber security and everything that goes into the costs of attack. So $400 billion worth of cyber-related costs and losses in 2015. So that's a pretty big number. This is globally. But that's an even bigger number. That's the projection from Juniper on where things are going to be in 2021. $2.1 trillion in cyber losses. All right, we're doing something wrong here, folks. Something's not working. And I think that the logic behind that rapid expansion is indeed this notion that we are going to move into an IoT world. We're going to increase all of these vulnerable access points and leave this gigantic pool of valuable data sitting there for people to attack. So, we have this problem, this decentralization force underway, the Internet of Things building in all sorts of directions, every bit of the world connected, and a sort of a centralization paradigm in terms of how we manage data. So the blockchain is different. And I think the way to think about it is the very concept that Bitcoin, Satoshi Nakamoto being the inventor of, is designed to focus on, and that is the trust question. So the reason why we centralize control of information and why we've done so for ages is to intermediate a lack of trust between economic actors. So we think about it as human beings, obviously, and that's what Bitcoin solves. It solves how do I, as a stranger, enter into a transaction with another stranger in a vulnerable environment like the internet and still feel confident that I'm not being defrauded, that the money that this person is sending me is legitimate, that their balance is actually accurate, and that the system is going to debit or credit the changes accordingly. And how do we do that in a decentralized way without having to have a bank or some other entity in the middle of that? That's the fundamental resolution. It resolves the trust problem. But if we think about it in an IoT context, it's actually not about people, it's about machines. So how do I know that the robot on wheels that delivers my milk isn't ripping off my fridge? We have to think about the identity of machines as much as the identity of people and the risks that are associated with those. So how do we architect an environment that allows for this peer-to-peer or machine-to-machine relationship without an entity in the middle of it in a decentralized way? The more we can do that, the more we think about that, the less data needs to reside in these big, vulnerable, centralized systems. But let's go back to think about where it all came from. This is Giovanni de' Medici. In many respects, I would argue, one of the key architects of the modern world. 1494, I think it was, stumbled across the idea that the banks that the Medici family were running out of Florence could be better run with double-entry bookkeeping. And as a result, turned banks into this intermediary between payers and payees. So rather than just being credit providers and matching savers with buyers, they actually function as a form of payment intermediary. So all of a sudden now a merchant in Venice could enter into a transaction with somebody in London with the bank debiting one and crediting the other account, therefore effectively creating a payment system. We haven't really moved very far from that model, 600 years later. It's effectively what banks do in the payment system. And the way they do it is they have this centralized ledger. They are the ledger keepers. And again, this is precisely what Bitcoin, and therefore DLT technology, digital ledger technology, and the blockchain that's come out of it is grappling with. The idea that we don't necessarily want to have ledgers controlled in this centralized manner. But as I say, there's a contradiction between this because the rest of the world is decentralizing. But we have a problem with privacy in all this, though. So how are we going to have a model that creates the ability to understand the risks that we face in transacting with each other, or that the machines face in transacting with each other, when there's this exposure in this transparent way, right? There's this privacy concerns. In some respects, we rely on banks to protect our information, to ensure that they are the ones that are responsible for KYCing us, determining that we are following Know Your Customer rules, that we're legitimate, credible people to be able to participate in financial commerce, but then protecting that information from outsiders, and so they don't need to know who we are. In an open architecture, an open structure like the internet, and therefore a digital currency type of structure, there is this concern of privacy. So we need to deal with this at the same time that we need to deal with this trusted structure. So there's the desperate need to fix it all. So Bitcoin became this solution. It is essentially a mechanism for imposing requirements on a network of validating computers to prove the information that's being transacted across them. And it does this, and this is the Bitcoin version. This is the truly sort of decentralized, permissionless network, as opposed to the more closed permission structures that really are emerging as one of the key focuses of digital ledger technologies. Under Bitcoin's kind of pure model, it's an incentive-based system. So the idea is, if I'm going to completely open up the network in a permissionless way, and anybody can participate in this, so I don't need to rely on an entity to determine who or isn't participating in the validation of the data, then I need to incentivize those players, for one. They need to be rewarded in some way. But secondly, and it falls into the same function, there needs to be this cost imposed on the ability of somebody to participate. And I'll go into why that's the case. That incentive structure, the cost of participating, is critical to the security. And if we think about IoT and the future that we need to build, it's this sort of cost and incentive-based structure that I think is going to be key to it. But let's also think about the structure of Bitcoin. So many of you would have seen perhaps this famous diagram. It dates back to the 50s. Paul Baran, who was one of the early thinkers behind packet switching and therefore ultimately one of the fathers of the internet, was trying to figure out how to keep the US intelligence data safe. And he stumbled across the brilliant idea that it's really not about having a centralized server in which you protect everything in a sort of a hubs and spokes model. And it's not necessarily either a decentralized system like that, where you'll have a number of hubs and spokes, but this fully distributed structure. So there's no center at all. And that's really important from the concept of security, because it means there are redundancies. If one node goes down, there's multiple backups for it. And this is one of the fundamental security aspects of a distributed ledger. The bigger the number of nodes, the number of users and holders of that ledger, the safer it is. If one ledger goes down, there are multiple other ones. It also means that the bigger that is, the harder it is to attack. And so what you have to achieve this in the Bitcoin world is this concept of consensus. So you have to get all of the nodes to agree that the transactions that are taking place across the system and being recorded in this ledger that you are all sharing is consistent, and that you all effectively agree that the next update to the ledger is going to follow that path. And there's various ways of achieving that consensus. In Bitcoin, it's a thing called proof of work, which means that this gets back to this idea of the cost of attacking it. Every single computer needs to conduct a certain amount of computation, engage in a kind of a puzzle, if it is going to participate in this validation process. And in Bitcoin, the one that is the first to achieve that puzzle is actually rewarded in Bitcoin. But if you wanted to take over the entire network, and there's like thousands of different Bitcoin nodes, then you'd effectively have to have 51% of those, and every one of those computers would have to conduct computation to do it. That starts to become very expensive when you weigh in there the cost of the hardware, the cost of the computing, but most importantly, the cost of electricity. So it gives you this kind of unbreakable consensus, because now, as the blockchain proceeds, and if you remember that the blockchain is a chain of blocked transactions, and it gets longer and longer. If you want to go back and change a block from, say, 20 blocks back in history, you have to conduct this massive amount of computation for each one of those blocks, win the block each time, and then reconstruct the history. So it becomes kind of very expensive to lie. And this is important because there's this concept called a Sybil attack. And Sybil is the name of a novel, I think it was in the 70s. It was about, what's it called, personal disaffective disorder. But we used to call it multiple personality disorder. And the idea behind this as a concept in network thinking is that in an environment like the internet, it's very easy to disguise one's identity. So this gets us to this problem of identity. So if we're going to maintain anonymity in a system that is decentralized, how is it that we can prevent people from just replicating themselves, lying about who they are, and therefore effectively taking over the consensus? So I could just become Michael Casey 1, Michael Casey 2, Michael Casey 3, 4, 5, etc. But the thing is, in an environment like Bitcoin, where there's this proof of work, and I have to spend money to do that, every time I try to replicate myself, I'm going to have to spend. In this case, on electricity and computation, right? How many times? Well, it depends on the size of the network, and it just becomes expensive to do this. So this is a fundamental feature of the security concept behind distributed ledgers, and particularly around decentralized ledgers like Bitcoin. And it is a remarkably ingenious way to think about security, because we have a different mindset now. We're not thinking about the identity of the individual and proving that this is a trustworthy actor and having to find out every detail about that human being. It could be that every one of those participants is actually a fraudulent actor. This could be ISIS behind this. The not having to know who that person is, but know that the economics of them taking over the world is so difficult that they can't, that's where we get our security from. So think about that as a totally different way to conceive of security. And that's really, I think, where we have to go if we're going to get away from this fundamental cybercrime problem that we're facing. So it's different ways to think about the problem, from the way we have it now under the centralized system to the decentralized system, can come down to a number of different frameworks. One is this concept of the shared secret model, which is the one we're most familiar with now, where we have something like a PIN, a password. There might be, and this is all shared with the centralized ledger provider, right? We're talking about the bank or whoever. They'll have our email or name, maybe our social security address. There'll be various other bits of data about me. And there might be a bunch of questions, right, to prove it. And then we'll have things like dual authentication and a whole range of ways to prove that this person is who they say they are. And it's a hub and spokes model. All the data sits in the middle, and access to that is determined by this shared secret that we share with each other. This is important when it comes to the way that you and I interact with our banks and do our online banking. But it's especially important inside an organization where there are employees who have collective access to this huge honeypot of data, and they go through this similar sort of process. Each one of those human beings is a fallible, potentially fallible entry point. Right? So there's this kind of human weakness problem that comes with this structure. The device identity model is a different way of thinking about it, and that is to say that rather than have the data reside inside this centralized structure, it actually sits on the device. So the individual holds their data. There's a whole lot of problems with this, which we'll come to in a minute. It's not an easy solution, but I think it has to ultimately be a part of the solution. And the reason why it matters is it gets us back to this idea of the incentives and the costs. If I'm a hacker, it's much cheaper to find some weak point here and then get into the big, multi-billion-dollar honeypot that JP Morgan is sitting on, than it is to hack every single device and just take little pieces of data. The cost-benefit payoff is obviously not nearly as beneficial. This is the incentive structure. So we go from this notion of fortress security to incentive security. But there are challenges. So the way that things like Bitcoin and pretty much every aspect of digital ledger technology for that matter are built, they're built on this idea of public-private key infrastructure. So that the key being, effectively a password, a string of alphanumeric string that is used for me to access my data. And we could go into the cryptographic details of it, but I don't need to right now. The problem with this, though, is that once we push all the data out to the edges and it's now sitting on people's devices and they have control of it, which is a wonderful ideal in itself. I think that's really beneficial for society on all sorts of levels. We do have to think hard about how we manage those keys, because it's not an easy thing to do. People don't, if all of your data, all of your precious value, and data in this case means money, is sitting and you've got control of it, and you lose the key, you literally lose access to that. So we need to think about how to manage that, which means that we may have to have third parties involved in key management. It may mean that banks end up being managers of keys effectively. But how do we construct that relationship so we don't just get back to the same old problem of having a centralized manager of all of this risky data, in this case keys, private keys. So there's and there are interesting solutions to this. There's a whole range of ideas around something called multi-sig technology and other things. So this is not necessarily a deal breaker, but it's something that's just very important in terms of these challenges. Another major challenge lies in the fundamental problem that the devices themselves could be corrupted. So, I think that this kind of utopian view of Bitcoin, for example, that it's once the data is important, we can trust it entirely because of the architecture I just talked about, forgets that we don't actually know that the keystrokes that somebody is making on their laptop or on their iPhone itself hasn't been corrupted because the underlying chip might have been corrupted. And there's a real concern about, can we trust the actual semiconductor inside? And Intel and others work hard on solutions to trusted computing around this. But how we trust this from a supply chain perspective, going right back to the very beginnings of where the chip was made, is actually going to be very important if we are going to architect an entire security model around this. And that in itself will need some sort of distributed system of proving the validity of the supply chain and the trustworthiness of the participants in it. There's going to be an interplay between trusted entities that certify and authenticate the participants in the supply chain, and there's going to be, at the same time, this kind of distributed ledger structure to it all. The goal of all this, I think, is something that actually my friend Pindar Wong, who may or may not be in the room right now, coined, and I think it's a great way to think about it, is know your machine. So those of you in the banking community and also just money services generally will know what KYC is, know your customer and how important that is to getting security around the businesses that we work with, we need to deal with this problem as well. How do we know the machine? Right? Whether it's the fridge or the automatic robot or whatever we talked about, can we trust it? Right? So those are the challenges. That I think is the solution, though, at the end of the day, if we're going to get away from this $2.1 trillion risk. But I don't want to leave you with the kind of negatives part of it, because that's to focus on the problems that we face, and rather think of this as being the opportunity that we face. This is actually, I'm going to use this actually does not come up very well in the big presentation. It's just like a bunch of blurred dots. What it's supposed to represent is New York after the superstorm Sandy that came through a few years ago. That's Lower Manhattan. The reason why it's all black, it really does look a lot better on my computer than it does up here, is because everything below 34th Street was wiped out. The grid went down and there was no power. But there are pockets of light because certain places, particularly around NYU and Washington Square Park, there was a microgrid that had been set up. And what a microgrid is a network of IoT devices, in this case solar panels, or there might have been, in this case, gas generators, but either way, it doesn't have a public utility managing the system. It's a localized grid, a microgrid. And these sort of microgrid structures are critical for security. So we've got, and the security doesn't have to be from hackers, it could just simply be from a storm, right? But the idea that we have a backup, a redundancy in the same way for our electricity structures is critical. So once we start to build these networks of interconnected IoT devices to do all these fabulous things, like give us a backup electricity system, but just as importantly, have automated cars interacting with each other and sort of engaging in payments with the city for their parking spaces and everything else. And there's multiple transactions that we envisage in the future where we remove all this friction from our day-to-day commerce and have this incredibly seamless relationship between devices that are all calibrated to reach optimal levels of resource usage. This is what the IoT future brings us, this prospect to create market mechanisms around microtransactions between devices and thereby achieve these kind of optimal usages of resources, whether it is how much of the electricity we use within a grid or traffic and dealing with congestion on our roads, right? All of this is the great promise of the IoT world, but it needs a security construct to deal with it. So this is why I say we have no choice. If we're going to move towards this world, we need to build this kind of architecture. We need some sort of distributed trust system, some sort of distributed trust infrastructure to allow it to participate. And whether it's the blockchain in a permissionless structure or a permissioned blockchain, or whether it is some other form of distributed trust whereby there's no centralized player in the middle of it, it's going to be critical. So this is why this technology matters, right? It's not just so that folks can get away with illicit fund transfers or we can imagine a world where currencies are issued without the central bank in the middle of it. That's really, in my mind, a red herring. It's the fundamental idea of the security of the data structure that matters.